All right. We are going to talk about, we're going to talk about graphing quadratic functions in intercept form. It's not in your note packets. We're going to sneak this in. Um, so it's just a different format of your equation. I do believe that was listed on the first day. So let's get right into it. So intercept form looks like this. Y equals, you still have your A, and then here you have your intercepts. You're multiplying them. So we're going to call one intercept P and one Q. So it's just a new format of a quadratic function. So to get your axis of symmetry, we're going to use an equation similar to what we did in standard form, but we're going to take the opposite of P and add it to the opposite of Q and divide by 2. So opposite of P and Q. So to get the vertex, we're going to use that what we had for the axis of symmetry, just like standard form for the x. So P plus Q divided by 2. Then we're going to plug our result in to the equation to get your y. So plug axis of symmetry in for x, just like we did in standard form. Now our x-intercepts are the place that your parabola crosses your x-axis. Sometimes it's 2, sometimes it's 1, sometimes it's none. But those are your x-intercepts, and you can get them by taking the opposite of P and the opposite of Q. All right, let's do some math here. All right, let's do a couple. So we need to find the axis of symmetry, the vertex, and the x-intercepts. Remember, to find the axis of symmetry, we're going to take the opposite of P, add the opposite of Q, and divide by 2. So this is negative half. So our axis of symmetry is x equals negative 1/2. We're going to take that axis of symmetry and use it for our x coordinate for the vertex. Then we're going to plug that in to the equation. So I have 2 times negative half minus 3 times the quantity of negative half plus 4, which gives me 2 times negative 3.5 times positive 3.5, which will give us a whopping negative 24.5. And I'm super glad we're not graphing this. The x-intercepts opposite of P and Q, so I have 3, 0, and negative 4, 0. All right, the next one, number 2. So we're going to get our axis of symmetry first. So we have x equals the opposite of P plus the opposite of Q divided by 2, which gives us negative 3/2, which is negative 1.5. So that's our x coordinate of our vertex. And when we plug that into the equation, I have negative 1 times negative 1.5 plus 1 times the quantity of negative 1.5 plus 2, which gives us a quarter. 0.25, a quarter. So our x-intercepts are opposite of P, opposite of Q. There we go. Lots of fractions. Let's do one more together. So number 3. So I have my axis of symmetry is the opposite of P plus the opposite of Q over 2. That gives us, oh, a little craziness. Again, negative half. So then I have x equals negative 1/2. Now I'm going to use that for my x coordinate and my vertex to get my y. I'm going to plug that into the equation. So 3 times negative half plus 2 times the quantity of negative half minus 1. All that gets me negative 6 3/4. X-intercepts are opposite of P and opposite of Q. All right, I'm going to pause here. I'm going to give you time to do 4, 5, and 6 on your own, and then I'll pop back so you can check your answers. Okay, here are your answers. You can stop it and check them. But now we're going to move on to the next part of your notes, which is some transformations. This should be a review, but it's worth reviewing. So when A is positive, your parabola opens up. When A is negative, it empties out or opens downward. So when the absolute value of A is greater than 1, we have a stretch. So your parabola will be skinnier. When your absolute value is less than 1, you have a compression. Some people call it a shrink. So it'll be wider like that. It's like somebody stepped on it. Okay, so let's do some practice with transformations. Here A is 2, so this is a stretch. Here A is negative 1, so this is a reflection. And here A is a third, so this is a compression. Okay, I want you to do 4, 5, and 6. There you go. Now you can take a minute and check your answers before we move on to graphing. All right, so let's identify what we are going to identify first. Let's get that axis of symmetry first. So remember, x is equal to the opposite of P plus the opposite of Q over 2. So I have positive half here. So x equals 1/2. So I'm going to use that for my x coordinate of my vertex. And when I plug it into the equation, I have 2 times the quantity of a half minus 2 times the quantity of a half plus 1. When all is said and done there, we end up with negative 4 1/2. My x-intercepts are going to be opposite of P, which is 2, 0, opposite of Q, which is negative 1, 0. Okay? So let's graph with what we have. Let's just graph the points we have. So I have half and negative 4 1/2, which is right there. Yeah, we got a graph in between the grid lines. And then we have our x-intercepts that we can plop in there. 2, 0, negative 1, 0. Okay? So we can do a couple things. If we want a few more points, we can use the table, but you don't really have to. But I'll show you how. So you can put in a half here and negative 4 1/2 in the middle because that's my vertex. So we're going to plop that right in the middle. So we're going to go down from there. So I'm going to use whole numbers, and then I'm going to go up, down to this way, up to this way. And you can plug into the equation. When I plug in 0 for x, which will be my y-intercept, which is really good information to have, my y is -4. When I plug in -1 for x, we already know that that's the y-intercept or the x-intercept right there. So when I plug in 1, I'm going to go back down the other way, and we don't even need to do those numbers because we know they're going to be mirror. Okay, so now I can just draw my parabola. So transformations, we know we can tell that this is a stretch because of the A. So stretch. Okay, the domain, same as always, -infinity, infinity. My range goes from lower to higher, so I'm going to start at 4.5 and go on to infinity. This is a minimum because it's a low point. The rest of the information on your notes we don't need right now. Let's do one more together and then I'll let you try one. So this is, we need to find our axis of symmetry. So opposite of P, opposite of Q divided by 2. So again, here we're looking at a positive half. Pretty popular answer here. So x equals 1/2. We already have our x coordinate of our vertex. I'm going to plug that into the equation to find my y coordinate. When that's all said and done, we have positive 6.25, or 6.25. We know that our x-intercepts are -2, 0, so opposite of P, and then opposite of Q. This is going to be loads of fun to graph. Okay, so let's find our vertex at positive 1/2 and positive 6.25, right about there. Okay, so if I need some more points here, I'm going to put that in the middle. Okay, then I'm going to use whole numbers. If I plug in 0, oh, there's my y-intercept, which will be 6. If I plug -1 into the equation, I get 4. So I'm going to mirror this so we can plot those points. I also know that my x-intercepts are -2, 0, and 3, 0. Okay, so my domain, typical -infinity to infinity in interval form. My range is lowest to highest, so I'm looking at negative infinity here, all the way up to 6.25. I'm going to use a bracket. That's a maximum because it's a high point. Let's go to transformations. So we have a negative sign here, so this is a reflection. It's -1. All right, I'm going to stop it. You guys can work on the last one. This has some nice even numbers. Okay, here's what your last one should look at so you can take a peek at that. And that is it for today.